Hi, everyone, and welcome back to Introduction to Artificial Intelligence with Machine Learning. My name is Mihika Singh, and I will be your course instructor. And welcome to Module 3 How Machines Learn. So far, we've built a strong foundation. We started by understanding what artificial intelligence is, and then we looked at machine learning systems as the core mechanism that powers modern AI systems. Now, we're going to take the next step, which is probably the most important one understanding how machines actually learn. In this module, we're going to move beyond definitions and start looking at the mechanics. We'll break down how a model takes input, makes predictions, measures error, and then improves step by step. You'll also be introduced to key concepts like parameters, cost functions, and optimization, which form the backbone of all machine learning systems. The goal here is to remove the idea that machine learning is a black box. By the end of this module, you should be able to clearly explain how a machine goes from making random guesses to producing accurate predictions, and more importantly, understand the process behind that improvement. So, let's get into it. Today, we are going to open up what is often called the black box of machine learning. When people talk about machines learning, it can sound mysterious, like the system somehow understands things or develops intelligence on its own. But in reality, there is no hidden intelligence. Machine learning is a structured mathematical process. When we say a machine is learning, what we actually mean is that it is improving its performance on a specific task using data. So instead of thinking about it as the machine is learning, I think we should think about it as optimization. Optimization is the process of adjusting a system to minimize error and improve accuracy. And in this module, we're going to break down exactly how that happens, step by step, so that the idea of machine learning becomes completely transparent. At the core of machine learning is a simple loop: guess, check, and adjust. First, the system makes a guess. This guess is called a prediction, which is the output produced by the model based on the input data. Then it checks how accurate that prediction was. This is done by comparing the prediction to the actual value from the data set. And the difference between the prediction and the actual value is called the error. Finally, the system adjusts itself to reduce that error. This process repeats continuously, and each cycle improves the model slightly. So, learning is not a single event, it's an iterative process, meaning it improves repeated through repeated steps over time. Now, for this learning process to work, we need three key components: task, experience, and performance. Now, some of you may be getting a flashback to Module 2, Introduction to Machine Learning, and if you haven't watched that video yet, please go back and watch it now. The task is what the system is trying to do. The experience is the data it learns from, often referred to as training data, and the performance is how well the system is doing that task, measured using a metric. A metric is a numerical value used to evaluate performance, such as accuracy or error rate. A system is said to be learning if its performance improves as it gains more experience. This definition allows us to measure learning objectively rather than describing it in vague terms. Now, let's define parameters. Now, firstly, a model is the mathematical structure used to make predictions, and inside the model are parameters. Parameters are adjustable numerical values that determine how the model processes input data. You can think of them as knobs or dials. Each parameter controls how much influence a particular input has on the output. For example, in a model predicting house prices, one parameter might control the importance of size, while another controls location. Learning is simply the process of adjusting these parameters to improve predictions. So when a model learns, its parameters are being updated. And to adjust these parameters, the system needs feedback. And this is where the cost function comes in. A cost function is a mathematical function that measures how wrong the model is. It takes the predicted value and compares it to the actual value and outputs a number representing the error. If the prediction is far from the actual value, the cost is high. And if the prediction is close, the cost is low. So the goal of learning is to minimize the cost function. It's important to understand that the cost function measures inaccuracy or badness in a sense, but it does not measure success. So the lower the cost, the better the model is performing. Let's apply all of this to a real life example. Suppose we want to predict house prices. The inputs are features such as size, location, and number of rooms. A feature is an individual variable used as input to the model. The model uses its current parameters to make a prediction. We then compare that prediction to the actual price, and the difference between the two is the error. Using that error, the model adjusts its parameters slightly and then repeats the process over and over again. And then over time, the predictions become more accurate. This cycle of prediction, evaluation, and adjustment is the core of machine learning. The process used to minimize the cost function is called gradient descent. Gradient descent is an optimization algorithm. An optimization algorithm is a method used to find the best possible solution to a problem. And in this case, the best solution is the set of parameters that minimizes error. A helpful way to understand gradient descent is through an analogy. Imagine you are standing on a mountain in dense fog. You cannot see the bottom, but you can feel the slope under your feet. So you take a step in the direction that goes downhill. Then you repeat that step again and again and again. Then eventually you will reach the lowest point. That's exactly what gradient descent does. It moves step by step in the direction that reduces error. One important aspect of gradient descent is that it works through small adjustments. Each step taken by the model is small. These small steps ensure stability. If the model makes large changes all at once, it could become unstable and inaccurate. Instead, it improves gradually. Over time, these small improvements accumulate into significant process. This is why machine learning is often described as gradual optimization rather than a sudden improvement. Now, the size of each step in gradient descent is controlled by something called the learning rate. The learning rate is a parameter that determines how much the model adjusts during each step. If the learning rate is too small, the model learns very slowly. If it is too large, the model can overshoot the optimal solution and fail to converge. Convergence refers to reaching a stable point where the error is minimized. So the goal is to choose a learning rate that allows efficient and stable learning. This balance is critical in training machine learning models. Now, machine learning operates in two main phases. The first phase is training. Training is the process where the model learns from data by adjusting its parameters. And the second phase is inference. Inference is when the trained model is used to make predictions on new data. So, training is where learning happens, and inference is where that learning is applied. A simple analogy is studying and taking an exam. Training is studying, and inference is applying what you have learned to solve new problems. Now, the ultimate goal of machine learning is generalization. Generalization refers to the ability of a model to perform well on new, unseen data. This is important because we don't want the model to simply memorize the training data. Memorization leads to overfitting. Overfitting occurs when a model performs well on training data but poorly on new data. You can think of it as overly fitting it onto the training data. Instead, we want the model to learn patterns that apply broadly. This allows it to make accurate predictions in real world situations. So, is what makes machine learning useful beyond the training dataset. Now, to summarize everything that we have covered, machine learning works through a loop of guessing, checking, and adjusting. A model learns by updating its parameters. A cost function measures how wrong the predictions are, and the gradient descent is used to reduce error step by step. The ultimate goal is generalization, not memorization or overfitting. In the next module, we'll explore different types of machine learning and how they vary depending on the problem. I am very excited to be teaching this course as the Leadership and Innovation Ambassador at the Innovation Hub. If you are someone who is interested in creating and collaborating in STEM with like minded peers, I would highly encourage you to join. Now, thank you for watching, and I'll see you in the next module.